Hi, everybody, and welcome to the Data Architecture Virtual Chapter. My name is Kenny Neal. Uh, this week we've got Brady Byrd joining us to talk about templates, images, and containers. Uh, I'm the co-leader of this chapter along with my partner Rob. Thank you all for joining us today. Some upcoming sessions of ours on June 13th, we're going to have Kendra Little doing her presentation on how keys and included columns work. If you want to register for that or any of these other ones that you see upcoming, you can do that from our website, which is dabc.sequelpath.org. We are sponsored first by Nutanix. They've been with us for over a year now, and then also by HBR. They're a new sponsor for us, and we're really glad to have both of them on board, making this possible for everybody. Coming up, registration is already open for Path Summit 2018. If you use our discount code right there on the screen, you can save $150 on your registration. And I believe if we get enough people to use our code, we'll get a free registration that we can give away to somebody. The pre-cons have already been announced for Summit 2018. You've got some pretty well-known speakers that are going to be giving presentations. Kendra, Kimberly Tripp, Bob Ward, among many, many others. There'll be some interesting stuff if you can get out there a day early, a day or two early. Some other upcoming virtual group webinars. There's ours again. DBA Fundamentals. It seems like they have a meeting every other day. There's some more coming up. Upcoming SQL Saturdays. We just had Dallas, and from what I could see, that went off pretty well. Houston's coming up, and there's some other stuff outside of the U.S. Those are like mini Path Summits. If you can get out to it, it's all volunteer run. They get some speakers to come out. It's a good day of just some free training. Highly recommend it. And that's all I have. So with that, I'm going to switch over and let Brady be the presenter. Thank you again, Brady.
Hello, everyone. I hope I'm showing my screen now. Let me move into presenter mode where it will promptly swap the displays in the wrong direction. No, it actually did it right. Okay. Well, hello, everyone. I'm Brady Byrd. For my day job, I work with a company called DB Maestro, and we're doing database release automation. So a lot of this subject material is near and dear to my heart. And so I was batting around the topics with Brandon Blevins, a member of the group here, and he thought it would be a good idea to to bring the topic in and try and fold in some of the ideas of the continuous delivery and container architecture into it. So with that, I'll get started. So when we look at some of the factors in modern database development, if you haven't already had CI/CD come down the pike, it's coming, and the main thrust of this is that people want to move to more frequent deployments, and it's been proven that there's a lower risk in higher frequency, lower delta deployments than there is in sort of waiting a long time and testing a whole bunch of features before you release them. There's a lot of tools out there in the marketplace to help manage that type stuff. Favorite free ones like Jenkins and stuff, but then you can go ahead and spend $1 million on IBM Urban Code if you want. But in the end, and this has really specific weight on the database worker and DBAs is that the manual work is very common at the database deployment moment in the release, and this is really not a long-term option. So if your current strategy has some form of deployment and this and that, and it stops in the middle for the database to be done by hand, you can bet all eyes will be on you if that continues for long. Couple other factors with infrastructure. Everybody knows this is one of the biggest revolutions happening in IT right now. This ability to have software-defined infrastructure, and databases, given their nature, have been very difficult to move into this realm, but it's happening. So we're starting to see containerized databases. We're starting to see just-in-time environment provisioning and stuff like that. And so this is going to be a factor in how people move forward. And then the other thing is that as the audit climate and as the need for documentation grows, all of the things that touch your database have now become audit artifacts. And so they have to be managed in source control. They have to be documented or at least cared for in some way that's archival so that you can always demonstrate how you did what you did. And then the last one is the hardest one to hear, and that is that, DBAs who have been, caring for the safety of the universe for so long now get lampooned as the barrier to automation. And the reason for this is pretty straightforward. DBAs have a lot of scar tissue because when things go wrong, DBAs get blamed, or at least they get called in as the last possible savior of a bad situation. And if they fail, it's somehow their fault, even though they didn't get them in that situation. So what happens there is that, we've got to turn around this image of the DBA, or at least change the perspective of it to say, well, the DBA is here to let you know what is the appropriate way to treat a database and what is the appropriate way to move change through a database. But that individual or that role is also amenable to automation and increasing the velocity of things. So where are we sitting right now? This was actually some research that DB Maestro did, and based on a couple of thousand respondents, but they were just looking at sort of the level of continuous delivery adoption there. And as you can see, databases are lagging behind, not all the way behind everything else. But then on the other side, I don't think the survey was done like one of those psychological surveys that builds in questions to factor out the optimistic results. And my guess is that people who are using simple scripts to deploy say, we're automated, but those scripts actually only work about 10% of the time. So it's I would say the number is actually lower than this. But the bottom line is the world has paid a lot of attention to automating application deployment and and sort of test data automation, all that. But not a lot of attention has been paid to the database layer. And so what does all this look like when we try and factor it into an automation scenario? And I know the title says continuous delivery and syncing and all of that, but I just want to get the landscape out there so that we know where it all is. And that is that we've got this database component of an application that needs to be deployed. And there's a methodology for application deployment that we as database folks have to adhere to, or at least participate in the way that's expected. So at the top layer, we have some sort of continuous integration, continuous delivery type tools, and these are driving the orchestration of the process. There's some way that they communicate with the individual pieces that are executing here. They've got to have a whole governance layer that says the right people are able to do the right things. And then there's sort of a progression of information that moves there. On the one hand, everything that is affecting change in the system should be stored in source control. And to that end, you should have a concept of version. Version has been a very elusive concept in databases. So being able to track exactly what a version of a database means is a real challenge, and we'll talk about that in some more depth. And then, what are the best practices? And this is just to get the change ready that needs to move forward through the pipeline. Then once you have that change ready, you have to store that change. And this concept of a definitive media library was was a term that was put out there. Immutable repository is another one. ITIL has a bunch of definitions of this type of stuff, but in the end, what it means is the things that you're going to use to govern your deployment should be put somewhere where they can't be changed in between deployments. And that way you can truly demonstrate that the same technique used to bring it through your testing environments is what you use to bring it to production. And then on the release management side, you need to be able to deliver this stuff in a window. You might only have a couple of hours of prod, or you might even be in a 100% uptime environment where you have to do a canary deployment to one segment and then test those things in isolation. And so there's what it means is that you really don't have time to hand build anything in production. It means when somebody says throw the switch, you've got all things in place to make that go. And then the other thing is you have to be ready in case it doesn't go and you need to roll back. And everybody that I've ever known who does database change cringes when someone says roll back because it's not a trivial thing most of the time. So how does this look like sort of functionally across it? On one end, chances are you're using scripts, and scripts are actually a best practice way of doing things. So these scripts are out there that are going to affect the database. They're going to make the changes, but we have to make sure that the content of those scripts is correct. We want to make sure they're not doing anything offensive to the system or potentially data damaging, dropping tables, etc. And so that that script content has to be evaluated. There has to be this concept that we understand our pipeline, and that's really the subject matter of this talk is that if we need to be able to say that even if they aren't the same, we know what each environment is with regard to the database. We have a concept of version. We can say, yeah, well, I deployed 7 new packages to QA, but I remember what staging looked like back when QA looked like that, and they were the same, and I know that staging hasn't changed because of ABC. And so that's that concept of validation that says we know that what we're doing to staging is going to work because it's similar to QA, and we already did it to QA, and we know QA is there. And most importantly, by the time we get to prod, we say we've tested these scripts on a couple of environments. We know the state of production, so we are definitely ready to roll with a reasonable amount of confidence. So those are just to give you sort of landscape background, what's going on in release management, and what are some of the factors we have to consider, because in the main challenge here is to say that as we make deployments, as we advance along this development timeline and life cycle, that we're always aware of the state of our database, aware of the changes in queue to be applied to that database, and how that works in relationship to the other databases that make up this environment landscape. So this has not always been an easy task, and I've got a little corny animation here to talk about it. So let's suppose you're doing your work. You've got an application development team. They're sending changes. They're maybe writing the changes themselves. And so you got a new version, and that version comes in version 2.3.0. And then you test that, and it's good. You say, great, okay, so that worked fine in development. And then we got 2.3.1 comes in, and we test that, and it didn't work. Well, now we're going to put in yet another script, and we're going to repair that with 2.3.2, and then maybe that works. And we say, good, okay, so now we've got that. Now we're going to move those into QA and test them there. And they test out fine in QA. So now we're getting some confidence going, right? So we've introduced 2 new versions here. They check out. We bring them over into QA. Well, they don't check out in QA. So now we got to go back to development and introduce those changes. We can't just repair them in QA and leave development behind, though there are some places where that happens. So now I've introduced 235 and 236. So now just take a look for a second at my landscape here. We've got 7 versions deployed in dev, of which 5 have been deployed in QA, 2 of which are currently failing and waiting for someone, to fix that. And none of this stuff has been moved to prod yet. So we're starting to get some heterogeneity in here. But the important concept to think about is that 230 or whatever it was, 229 was the syncing version before all of this. That was the last major production release. And at that point, we knew exactly that dev, QA, and production were in alignment. And so if we actually knew from our dev environment exactly what it looked like when each one of these versions was deployed, then we would have a template to look at any other environment in the landscape. So if you think about the cost of snapshotting each environment, or doing just dumps and storing that information, that's big bucks for storage. But if you can be intelligent about a templating system and say, I know the DDL configuration of my environment before and after each one of these deployments, then I've got a very lightweight way of understanding the whole landscape there. And I can always apply that. I can use it by proxy. I can say, I can start from 233 and go over and say, what did 233 look like on QA? How does it compare to 233 now? So these are some of the great templating ways that we can look at databases. But I got sidetracked there. My whole point was to show you how we move through all of this. So we've got yet another testing failure here. We bring over 237. That looks good. So now I'm going to bring that over here to QA. It looks good in QA. Finally, we can make our release to prod and bring everything back in alignment. But recognize that for the entire duration of this release cycle, none of the 3 environments were the same except for very small points in time. So a lot of the tooling that's out there that does application release automation assumes that you can just rip and replace. Hey, it's a Java app, just throw the jar away, and then bring in a new one and everything's done. And they fail to take into account the cumulative nature of database change. So whatever we do in this world, when we move to automation, we have to accept that we're going to have to track on an individual basis the queue of changes that need to go into any environment. And as we know, as database people, order is critically important in this. When you start putting packages out of order with one another, dependencies fail and objects get invalidated, and then it's another mess to work with. So what are some of the strategies people use to keep all this together? Oh, there's another check mark to go. That means we were successful. So there's 2 different sort of 2 main strategies out there. One says, and I've changed it to intelligent version management, but it's basically delta deployment, right? We can go in, we can compare 2 schema, and we can say, I know what the differences are between these 2 databases, and therefore I know what needs to move forward. And then there's what we call a migration strategy. So in migration strategy, you say, well, the sum total of each change made to the database, if you place them end to end, builds your database. Now, I got my roots in Ruby on Rails, and active record migrations is the way that Rails works. But you think about it, well, that's kind of it's a great way to work. I love Rails, but the fact is, with a Rails app, you start with Rails, right? You start with a database that is empty, and every single migration you put in is exactly what's there. And Rails makes all of these nice tools so you can constantly update that, and it knows how to run through the migrations, and everything works well. But that usually doesn't work for an enterprise app. Lots of us work in big companies where you walk in the door and they sit you down and they say, this app is 25 years old. It has all the crimes of history in it, and we want you to start here and make it better. And so it's there's a lot that can go wrong there. So migration strategy, my summation of that is that while it's functionally true, it's behaviorally false. And the reason that takes place is that there's all these ways that it does get out of alignment. You think you're saving every SQL script that's ever been run about on your database, but you actually don't know the initial state. Like I said, it's 25 years old. It has all the crimes in it. So it's sitting there, and so you don't know the initial state, but now you're keeping assiduous track of everything that touches it. And then, but suppose somebody is doing, you've got a crisis of performance, customers are complaining, and somebody sits there for a day just hammering at it, creating indexes and combo keys and all this sort of thing. And maybe they document everything, maybe they create scripts for everything, or maybe they just fixed prod. And it's up to you to find out what that was. It's not unusual to have like third-party apps making contributions to things. Maybe there was a patch installer that came in, the change was sort of out of your hands, but it got done anyway. How do you quantify that? Prod outages, or just the classic, we've got multiple teams contributing in an environment and they're using different techniques and not talking to one another. So maybe some people are documenting their work well and some aren't. In the end, if you did take every script you thought was necessary to move the database from one state to another, you might end up not getting there. So I think this needs some bolstering. So that's migration strategy. And migration strategy is supported by a lot of products like Flyway and stuff like that. And I think it holds. It's good. It's obviously an essential practice to store every script you use to modify your database. But I think it also needs some support in storing the resultant configuration as well. So this is the part that gets a little shameless plug, but I won't mention DB Maestro any more than I just did. So the point being is that it's well worth it to track that configuration of the database, and almost any database that's worth its salt, DB2 notwithstanding, you can ask a question of it. You can say, "Dear database, give me the DDL of this object," and it does, and it gives it reliably, and it's the same DDL that would recreate that object if you turn around and ran it as a script. So what we can do is employ this capability, either using dump files or DAC packs or whatever you want. But you can. The important thing is that you can record the total state of the database, or maybe the total state of a certain set of objects you care about in the database, and push that into source control. Now you have another data point, right? You not only have the script that changed it, but you have the resulting state. So consider all the advantages this gives here. Now we're going to pick up things like differences in initial state. We're going to pick up what those exact performance fixes were. We're going to see the changes that came in from that patch installer because we can measure it via delta. But as we know from script generation engines, never really trust a script generation. Never trust your children to a script generation. And we all know that our production databases are our children. And because what happens is that script generation engine is going to have a strategy, a philosophy, a set of rules that may not create the best possible script to make that change. So in a lot of ways, the handwritten scripts will outperform the engine generated scripts. However, what the engine generated scripts give you is they give you completeness, because the engine isn't going to miss something because they forgot to look in the functions folder and see the change there. What the engine's going to give you is it's going to show you every object that's touched. So you kind of need both, right? You need to have that understanding of state, and you need to have that understanding of the migration. So I'm saying, neither one is the winner. You got to have both. So if you're going to be working with with this. And this is really important for that whole syncing task, because in the end, when the big boss comes down and he says, we've got a lot riding on this release, customers are counting on this new functionality, are you confident that everything's going to work tonight? And you say, yeah, sort of. And it really, you can be a lot more confident if you can say, hey, I went out and I was able to measure the configuration of production. I know nobody was mucking about in production and changing things because I'm able to measure that. I know that it looks just like my staging environment where I ran these scripts just yesterday and they succeeded. So yeah, I have a lot of confidence that we're going to get there. And that's because you've got a sense of version. You've got a sense of the agents of change, and you've secured them so that they're the same scripts and same automation that were applied in the previous environments. And you've got the resulting and before states, so you have a pathway back if things go wrong. So this is a much more, it's a more analytical approach. It's not quite the faith-based way of like, yep, we're going to try it, and here they go. So it's a good way to approach it. So let me recap for a second, and I'll open it up for any questions that people might have at this point. To recap, DevOps, that's who's driving the bus, right? It's been the buzzword for 10 years now, and virtually every CIO has it on their top 5 list. So this is what people are pushing for, and the main reason is because the business wants change delivered more quickly, and they want this increased velocity. We've got tools that have been helping apps, but not necessarily databases. There's a whole order and structure to the release and deployment that has to be regular and predictable, and that flies against the more customized approach that database change has taken before, where there's some examination, some comparison, some things there, and then there's an overriding strategy that if you can have a document-defined process, then you have the best chance. And that's sort of just to give a little explanation. In the Bible book, Continuous Delivery by Jez Humble, he points out that if you can have a document or better, a script that relies on some set of inputs and settings and stuff that are all documents that can be run for every stage of the development lifecycle, then your chances of achieving continuous delivery go way up. For everything that falls outside of this, that is a manual change or even a fully separate product that doesn't support the idea of a document-defined process, is one more impediment to reaching the goal. Database changes are cumulative. That's all the education you needed today. Nobody knew that until I came into the room. But what it comes down to, the fine points are that this challenge of recording the queue of changes that's necessary to keep each environment in sync with the others can be a real bookkeeping nightmare, especially if you're accumulating dozens or hundreds of changes between environments, or you have a complicated hopscotch of environments. Some are used in major release, some are used in minor. It can be quite challenging to track all that information. And in the end, what it means is that we have to know the version of our database. So we have to have some way of being able to measure that. And we just talked about the migration and the Delta strategy and my advocating for a hybrid thing. So I'll pause here if anybody's got some questions or wants to relate some information on the topic. I'll actually just pause so I can drink water. Let me just double check the chat and see if any questions have been lobbed in there. Okay. Once again, my explanations are perfect, so there's no questions left over. So what I'm going to look at now is a little bit about the, if I click on the right window, is a little bit about the sort of automation scenario, and this is to say, there is a school of thought that says, we're just going to write good scripts, we're going to run those scripts against the database, and everything's going to work, right? And so I've got my little environment progression here, and we wrote our script, we executed it against, we've got a team of developers over here, they're all blue, and we execute against integration, that works, QA works, staging works, production works, we are experts, this is cooking, and then the next one comes through, and what happens is this development process gets in the way. We have multiple developers. We use elaborate stored procedures. And it just so happens that even though we thought they were working on separate tickets, they ended up working on the same stored procedure. The last person wins when they save, and now we've got an incomplete set of changes going forward. So that's a merge conflict. Similarly, let's suppose that QA was debugging a problem, like I mentioned before. They're doing some performance fixes. They're adding some indexes and stuff like that. But now that means QA is not the same as integration, and so your scripts might fail. Similar way, the break glass scenario where there's an emergency fix. They just did it in stage and moved it to prod. Now you run the risk of moving that, of erasing that change and pushing the problem right back into prod, right? So there's lots of ways that a simple script-based methodology can go wrong. But what are some ways that we can fix that, right? If we were able to see, from our sense of version and merge capability, if we were able to know what each developer was doing and what objects they were touching, well, that saves us a whole bunch of headaches, doesn't it? So now you can get rid of that problem just by keeping better track or having the formality of checking out an object and saying, I'm currently the one working on that. In the same way, if you could measure that QA environment, remember what I said about the templating capability. If we know that integration is our standard and we know exactly what QA should look like, and we have a method for measuring that, even just as simple as a dump and a diff, right? Then we can say, hey, wait a minute, somebody was messing around with QA, and we need to get back to that. A simple schema compare, and we could probably build a rollback to do that. So that way we can say, we can identify some sort of a drift out there, and then we can pull back and bring it right back into alignment. So now we're working once again with apples to apples. So that helps a lot there. Same technique, in terms of the prod outage, prod fix there. Validation catches it. Now you can take that important change, percolate it back through your pipeline, and make sure that you move it forward to prod. So they're just simple steps. They're simple ways of keeping track of things. But once again, this is using a couple of the things. We've got the templating scheme, and we have schema compare are the techniques that we're going to be using to track a lot of this stuff. So then that helps there, and in the end, you can remove a lot of the barriers to keeping your script-based system moving and getting changes into prod. So now let's just take a look at what what that all boils down to. Version management, gotta have it. Gotta have a way of not only declaring a version, but a way of analytically calculating that version, right? Saying, I know that database is that version. And this is really important as we move into more transient environments and being able to know versions analytically. Automation, we have to reliably be able to move change, right? We have to respect the version control process, not subvert it when we do automation. And then being able to do a rollback, how to undo things. And then being able to do this in concert with the application release. We don't want to set up a totally separate process because then we're not going to lend ourselves to full automation. And then the governance piece, you got to be able to demonstrate what you did always. So how does this fit with our containers piece here? we've got some great technologies out there that are really reaching maturity. You know, the Docker and Kubernetes and stuff. I mean, everybody already has virtual machines. That's not a problem. We can provision whole machines and provision them with reason. You know, it takes all of like 8 minutes to get an Amazon instance, so it's not exactly a big time sink to get it. But how does this work in relation to the database, right? Um, you know, these containers can pull in configuration, they can change themselves. But when you have a container, if you had to move like a boatload of data in and out of a container every time you instantiate it, well, then you've really set yourself up for a sort of a much slower process. So how can we take advantage of this ability to to pull in uh, things in this containerized way, and make use of them in our pipeline, without violating all of the things that make databases important, and that is that they're static, they're cumulative, and they generally manage a large amount of data that would be inconvenient to pop in and out. And so where it really comes down to is in testing, right? It's this ability to instantiate a test environment, and run tests on it, and have that test environment be the same as we approach automated testing, and really get into that continuous delivery sweet spot. We're going to have to be able to to get to restore a known configuration and data set, because that test automation is probably counting on having 17 users named Smith and this sort of stuff, because that's a lot of the way that you can do a sequential ordered test, a functional test of the database or of the application, manipulating the database. And so you got to have that test data in there. So and curating that test data is a it's a whole industry, right? And so being able to get that test data, that's the same every time, and every time you run your tests, you've now destroyed that test data and you need to bring it back. So how do we work with this? And I think containers are a great way to do that. But the thing that they're missing is what I call the final mile, right? So during the time from when you made your last image of your test database, to now, what deployment work has come? And so let's say we've just used our Docker container and we restored, boom, we've got it there. Or maybe we're using Delphix and we just popped up a new image of the database, but then it's actually not at the current version of the rest of the pipeline. So now we go back to that slide we were looking at, where we've got the pipeline in various states all over the map, and now we've just thrown in yet another environment of perhaps even indeterminate state. You say, well, when did you take that backup? Well, that was Wednesday night, but not necessarily that was version 2.3.5. So how do we get to do this? And that's part of that, having that template plus version analytical capability of measuring where you're at. So now we restore a database, we measure it, and we say, okay, cool, I know where I'm at. Can I do a delta from that to the known version and generate a script? Yes. Now I can update that one. Boom. Now I have just-in-time test environments. So that's where I see it going, and I think the idea of having your production in a container, I don't think so. I think that's a ways off, and containers haven't been that rock stable either. But I think we can do a whole lot with the way pre-prod works, with sort of virtualization, containerization, stuff like that. But even if we don't get into that technology, the whole ability to use a templating strategy, a different strategy, a migration strategy, allows you to have a number of environments where the relative differences and the relative version of every environment in your pipeline. And this is it's a whole lot less mystery than most of the development pipelines I see now. So at this point, I was going to open it up for some discussion questions. That's all of the sort of formal presentation, but I would like to hear any plans and products and techniques that you all are using. I'm keenly interested in sort of where the group is at with adoption of these type of technologies. So let me open it up for questions there.
There's already kind of a softball question sitting out there for you, Brady. Can you suggest any product to do database version control?
Boy, is that a softball question. I would say maybe DB Maestro. And there are things out there, that there's several different products out there. A lot of them use a migration strategy to look at things. So they're out there and they say, we'll keep track of all your scripts, and then we'll push those changes forward. And like I say, there's a lot of good value to that. Products like Redgate actually do track the configuration of the database, the underlying configuration. You can do this with DACPack as well, just scripting it with Microsoft's own built-in tools. DB Maestro does just that. It puts a wrapper around DACPack, but in a more sophisticated way rather than 62 command line switches. And so so it's this ability to understand and follow the deployment process as you move through version space, knowing at each step of the way what the total configuration of your database is and the total difference between that and the next one. So I'm obviously a fan of DB Maestro, and it's a good way to support having both a nice streamlined automation strategy while having the safety layer of keeping track of the exact configuration underneath it all.
There's another question out there. Can templates, images, and/or containers be used in any way with the
questions? Okay.
Azure SQL database?
Yeah. Now I see questions. Okay.
Okay.
Not that I can stretch that part of the little control panel to read them, but oh, there we go. Can you suggest? There we go. Can templates, images, or containers be used in any way in Azure SQL database environment? So yes, Azure SQL has a little bit of has some limitations in how you approach it. In fact, you kind of have to have everything in Azure be essentially, it just has to be a SQL script, right? So you have to use a full SQL dump to load a database and everything like that. But you can still use the same methodologies that I've been describing. So containers, no, you can't do that. But that ability to say we've got an image stored as a dump, we have a template that we can reach out and measure, because you can use SQL commands to measure what's going on in your Azure SQL database, and so yeah, you can apply a lot of these same techniques. Some of the more sophisticated and like the speed of a truly containerized strategy, you can't do that with Azure SQL. But the nice thing with Azure SQL is that you're not limited so much in scale, so you can pop new instances up and feed them and then shut them down and stuff. So there's a lot of ways to make it work in Azure SQL. Let's see here. Where do you get DB Maestro? Well, dbmaestro.com, of course. So and it's so we're DB Maestro is it's an enterprise product, but it also sort of it can scale up or down to suit the needs of medium-sized companies. And the the principle of it is that it installs several services, and those services will watch the databases that you're working on, and then as you do deployment work, that triggers the tool to take essentially snapshots, but they're lightweight snapshots because they're essentially a delta snapshot of just the structural changes that happen between things. So talk to us if you want to get DB Maestro, and we're always happy to help on that front.
If anybody else has questions, go ahead and type them into the question box.
Is anybody actually using containers right now to move databases around? I can make it a poll question.
I'll go ahead and answer that one.
That sort of confirms a suspicion I've had, which is that there's been a lot of talk about containers for databases, but I think a lot of people are leery of it because of the, I guess there's a little mystery surrounding it, especially in a SQL Server group. Containers really haven't reached full maturity on the Microsoft platform yet, although SQL Server for Linux is here and now, isn't it? So we can get there, but those it's I'm confident of the value of containers because of that final mile thing. So if we use these strategies I've talked about to be able to identify version and make up that gap of the final mile, then these containerized databases really start to make sense. And then you can have sort of on-demand environments that can be instantiated in a matter of minutes, even at like terabyte scale, for testing, and then disposed of with technologies like Delphix and stuff. You can do that.
One more question that came in a minute ago. You mentioned the ability to definitively define if a database is at a particular version. How would you do that?
So I'll tell you the way we do it in DB Maestro is that we take an image before, right? So we look at the state of your data, and DB Maestro is not too concerned with the data, where it's mainly looking at the DDL changes. So I'll just that caveat aside, just thinking about the structure of your database. So what we do is that before deployment starts, we take essentially a snapshot of the DDL. Now there's an initial snapshot that took place some time ago, and then we only update the pieces that change. So these are very lightweight as you move along. But so now we know the before state, right? Now we run all of those scripts, and let's suppose we had 22 scripts to run, and at script number 17 it died, right? And it crashed. And so now we say, oh my gosh, well, where did we get to? What did we do? So now what we can do is we can say, I know where I started, and I have that configuration saved. Now I can take, and essentially I'm just doing a DDL compare object by object of what's in my pre-image, and comparing it to the live state of the database out there. So DB Maestro uses essentially the .NET components on SQL Server, and also, for Oracle as well, we reach out and we say, give me the DDL of your object. Cool, compare regular text-based diff right through the list of objects, and that way we can tell the exact deviation of that live database from our last known good state. So it's a templating strategy essentially for doing that. And what we can do is buy this idea of a label or of a pre-label. Then we can say that version, that configuration label represents version 1.7, and then we can look at any database and say the pipeline is at 1.7. Where are you at? Well, you're missing this, this, and this, or you've got these extra things that you need to get rid of. And we do that just by that difference measurement. Now, I like the checksum idea. That's probably a good first crack at it. That you could do a DDL dump of the database. And if the checksum matches, that's one number, right? And so it's very quick to do. And it goes, that'd be one approach. We take the sort of more sequential, detailed approach so that we can report on any differences individually that we find. Let's see, what do we got here? Does DB Maestro have a developer edition? I wish. I've been pushing for a downloadable developer edition, but for right now, what we generally do when people want to just take a look at it is we can spin up an Azure environment for it for a little while so people can examine or run a POC on it. And then without microservices driving the architecture, I don't see how they're useful for production operations. Did take a look at Delphix. Yeah, I would agree with you in terms of production operation for containers. I think, especially with regard to the data layer, persistence of the data is too important to rely on the sort of ephemeral container. I think containers really work well for compute, and they really work well for sort of transient operations, but for persistent operations, at least at the maturity stage of containers now, I would be reluctant to put production data on them for that. But Delphix is a very interesting technology, and Actifio does similar type stuff. Their whole thing of running an appliance, and in that appliance they have compressed databases. But then what they do is like just add water pop-up. They basically trick the platform into believing that database was always there. So they just go poof. It's the storage is attached, the volume is there, the database platform thinks the database has always been there, and now you've got this nice, happy database to use. And not only that, they can do this in an instance capability so that they, let's say you've got a 5 terabyte database, they can instantiate that for one application and then use the exact same image to instantiate for a different application, and on and on and on. And so you get this huge economy of scale because you're no longer having to dedicate an entire database per application environment. You can just be swapping around the image that you're using. So it's really quite sophisticated. Let's see, any other questions rolling in? Oh, here we go. As long as the containers are not part of multi-tenant. That's interesting. Is the performance on par with bare metal? They have demonstrated that container performance loss through containers is tiny. I mean, it's real, but it's tiny, and that's because, at least, and I presume that the Windows containerization strategy works similarly, but I do understand a bit about the Linux containerization thing, and that is that I guess it was way back, what was it, like 2.3 kernel of Linux, they gave this ability to say that the entire kernel runs essentially in an envelope, and that envelope could be instantiated or as a document. And basically what would happen is that when you throw the kernel in that envelope, the envelope defines all the storage, all the everything about it, all its network connections, everything that the kernel needs to connect to and that you can swap it around. So now you've got all the compute, you've got your processor, you've got all of the OS code and everything like that sitting there, but you can just quickly slip this new envelope around it, and it thinks it's in a completely different computer. And so that switching is very, very fast, and it's also very lightweight because you're not really moving a lot of data around. You're just basically switching out the locations of things as far as the object is. And at least on most OSs now, the days of interrupt 12 are gone. And so most people, most of these things are already abstracted through several software setting layers. So adding this other setting layer of the container is a minimal amount of overhead. But multi-tenant is an interesting piece. I'm not sure how that would affect it. Yeah, it requires a little bit of thought, but I don't think it should affect it that much. And the final one says, thank you, and you're welcome. So,
I think that's it. Thank you very much, Brady.
okay, you're
I really
welcome.
enjoyed this. All right. Thanks, everybody, for joining us today. We'll get this recorded and posted up as soon as we can, and we'll see you on our next meeting on June 13th. Thanks again. Bye-bye.
Excellent. Bye-bye, everyone.